For this second video of this 7-part series, we're going to look at stratified sampling. I need to state before we begin that this is a random method of sampling. We might as well have a look at the definition so we can break it down into detail and understand exactly what the process is. Stratified sampling can be described as having members of each stratum, we'll discuss later what this means, in proportion to the size of the same stratum. The sample from all strata is selected randomly, as we clarified earlier with it being a random sample type. So what does stratum mean? Well, this is quite simply a fancy term for groups or categories. The most common that gets taught is year groups, but it could also be cars, genders, subjects, whatever you like. And hence strata is the same, but just the plural for stratum. If we look to break down this definition into something that makes a bit more sense, then we can gather this as a sample with members from each of the categories. The number of this sample for each category essentially reflects how large that category itself is. Don't worry if this still doesn't make sense to you. The exams won't ever ask you to just spit out definitions, so just stick along while we go through an example where it should make much more sense. At the end of the day, it's just intuition. One more thing before we start, the groups cannot overlap. So one example could be car type. Check any car that either support petrol or diesel. Not both as far as I know anyway. So they are not overlapping and could be used in a stratified sample. However, if we're looking at subjects, for example, you can do maths and PE. So if we're looking at anything to do with this, then it may not be entirely feasible, as you might have students doing both of these subjects. So just focusing on how it comes about rather than memorizing the formula without any understanding is very important. Take this school. It has 100 students and the respective numbers are shown per year. The head teacher would like to hold a meeting with 10 students from the whole school, and it needs to be representative. My video on populations and sample covers this terminology if you need it. Our aim is to see how many from each year should be in this sample. So we now have the information that we need. Let's look at year 7 first. The table said that there are 20 students in year 7 and this is out of 100. So as a proportion, which basically means how much of the total it represents, we can rewrite this as 20 over 100. Now from GCSE maths, you should be comfortable with simplifying fractions. We can take a common factor of 10 out of this. So if there are 20 year 7s in a group out of 100, we can try and replicate this in a group of 10 with 2 year 7s. Okay, with this reasoning, I'm going to quickly breeze through the rest of the years. In year 8, there are 30 students. 30 out of 100 simplifies to 3 over 10. So for our sample of 10, it makes sense to use 3 year rates to best represent the school as a whole. For year 9, we also have 30 students. Using the same rationale, we'll also gather 3 students. And lastly for year 10, 20 students from a sample of 100 can be shown as a fraction of 2 over 10. So 2 students in our sample. So let's add this up. 2, add 3, add 3, add 2. That gives our sample of 10. And from here onwards, remember that we take a random sample of the population. You might have spotted it instantly, you just divide by 10. If the question is as easy as that in the exam, then great. But it likely won't be, so the idea of proportions will come as a great help when it's not too easy to spot. So now you get the intuition. The formula without understanding it will get you nowhere. So hopefully you now understand the idea behind stratification. So we can describe the number that you will sample from each group as the number in the subgroup or strata that you are interested in, and then divided by the population. Lastly, multiply by the sample size. Once again, all these terms are covered in my video Populations and Samples. This is an extension for those who are mathematically confident. Notice in our previous example we just divided by 10, and we skipped from the fraction straight to the number in our sample. But what we should have done per se now we have the formula was multiplied by the sample size. In this case it was 10. In doing so, I would have eliminated the denominator. A lot of things were very simple with this example, but I chose this because it shows the mechanism of the formula. Okay, so now we have the formula, let's actually attempt the question to see what we could actually be asked. We are told that a secondary school contains 5 years this time. A news reporter would like to know if his pupils are enjoying the year so far. Now we have this table showing the number of students per year. and the report is limited on time, hence she's only going to interview 30 students. Carry out a stratified sample to show how many students from each year should be selected. Let's just look at the formula first. At the core, we have 3 elements: the strata, which in this case is each of the years. Another thing we need is the sample size. Skim the question and you'll see that it's 30 students. This is the number of students you want us to interview. And lastly, in order to answer this question, we'll need the population. The population is just the total number of students. It will be helpful if we add up all the years. So 112 plus 127 plus 136 plus 109 plus 84 gives us 568 as the population. We'll start with year 7. There are 112 students, and this is out of the total of 568. We need to multiply this proportion by the total sample size, 30 here, and we obtain this value, 5.91 and so on. We'll explore some more complex cases in a bit, but for now, just random will do. And so we need to interview 6 year 7s. For year 8, there are 127 students. We can represent this as a proportion by dividing by 568, and again, we'll multiply by 30 to end up with 6.70 and so on. We'll round this to 7. For year 9, we'll write it as 136 over 568 and multiply by 30, putting it into the calculator, round and get 7 again. I'm going to skip the workings for the last 2, or we'll be here for a while. Take this chance to do some workings yourselves and check the answers in a minute. If you did it yourself, you should get that year 10 needed 6 students and year 11 needed 4. A useful thing to do is to add all the numbers up together. 6 plus 7 plus 7 plus 6 plus 4 indeed does give us 30, the original sample size. However, as we will now see, we might run into some issues that you might have not been aware of. Take this question. A company would like to survey 25 gym members. To add to this, there are 3 types of members: standard, premium, and student. The table below shows how many members there are for each type. We need to carry out a stratified sample to see how many of each membership type should be in our sample. Have a go at the question, as it will be good practice to make sure you've understood. I'm going to breeze through the calculation path as that's not the focus here. We're given the total, 100, and we're also given each strata and a sample size of 25 here. For the standard type, we'll do 47 divided by 100 and then multiply by 25. This gives us 11.75, and as previously, we'll round it up to 12. For the premium, 38 over 100 and then multiply by 25. Rounding this answer, you should get 10. And lastly, the student type, 15 over 100 multiplied by 25. Rounding this, you get 4. Quickly add this up and see if you notice anything. You should gather that when you answer these 3 numbers, we add them up and we get 26. But we were only looking at a sample size of 25. Well, a common problem here is that sometimes you need to round with respect to the bigger picture. We've gone over by 1. If you don't see what I mean, we wanted the sample of 25 as per the question. But from our workings, we are basically taking a sample of 26 people. So for one of the groups, we are sampling 1 too many. This table has the exact values shown from our calculations. Now, if one of them is too high, carefully consider which one we should round down. So look at the decimal parts. We have 0.75, 0.5, and 0.75 again for the 3 numbers. So while this means that we should round them all up, since this adds to 26, one of them needs to be rounded down. And at GCSE, you only really need to understand that it's the one closest to the lower bound of the number. 9.5 is closer to 9 than 11.75 is closer to 11, and the same goes for 3.75 compared to 3. So from this, we need to choose 9.5 as our answer to round down. So the actual answer is 12, 9, and 4 for our respective samples. Add them up, and they do in fact give 25. It's a tough thing to get your head around at the start. If you don't understand, try to rewatch the snippets and take it in slowly. This is around the higher grade of understanding, from being completely honest. I'll put in a summary here for your notes. Step 1. Identify the population. This is your total. Anything from students in a school to red cars in a parking lot. you need to be confident in knowing what you are actually working with. Step 2, split this into categories or your strata. Make sure that they are non-overlapping. Step 3, you need to work with the sample size. If it's not given in the question, chances are you'll actually have to manipulate the formula to find the sample size itself. In the exam, usually the first 3 steps are presented to you in the exam. So other than highlighting the key info or whatever other method you use, this is minimal effort. Step 4. Now you have to use the data you found and put it into the relevant places in the formula. For some of them, it'll be a simple plug and go. However, harder questions might require you to think that little bit more. Step 5. Round the numbers as appropriate. If they don't add up as we saw previously, you'll need to inspect and round up or down to get to the required sample size. Lastly, Step 6. Select your sample randomly. This isn't a huge one. It's often not even mentioned too much, just something to be mindful about. This is the opportunity for you to have a go at some exam questions. Remember, we've covered everything here. If there is something you don't understand, try and think about it from a different perspective. Use any formulas you know, and any pieces of info that might help you get to the answer. Pause the video and we'll go through it after. So let's read the question. A school has 200 students. All students do history or geography, not both. Sam takes a stratified sample of females who take geography. He finds that the value of the sample for the strata is 9. Using this information and the table on the right, find the sample size that Sam uses. Quick side note, you might remember at the start I said we cannot stratify if the groups overlap. While this is a question on subjects, we can assume that you cannot take both of the subjects here. Okay, back to the question. I'm going to put the formula on the right hand side of the screen here. There are 4 elements to this: the sample itself, the strata, the population, and the sample size. The question wants us to find the sample size. Now you can do this in 2 ways. If you are confident manipulating numbers, then you can use this formula, plug the values in, and rearrange as appropriate till you find the sample size. I'll do it the other way too, rearranging the equation first. You can see that we are dividing by the population on the right hand side of the equation. The opposite of this is the multiply. So essentially, we have the stratum sample multiplied by the population, which is equal to the strata multiplied by the sample size. Since the strata is multiplying by the sample size, we need to divide by the strata. Doing so will give us this formula below. Just pause the video for a second if that was too fast. Make sure you get how I rearranged it. If you're a bit shaky in rearranging, watch a video on how to do this. I'll try to link one in the description. That was honestly the hardest part of the question. From here, you just have to have your calculator with you and you can do it very quickly. I'm just going to substitute what I know. The strata for his sample was 9. It says that in the question here. We'll put that in place for the first formula. Now that is the actual strata. It's geography students that are females. Now look at the table and identify what value that is. Take your time to see which value it is. You should have seen that it's 61 students. I'll sub that into the equation, and the total we can gather here from the question is 200. We need to eliminate the fraction. To do that, we need to multiply by 200. Lastly, all of the left-hand side must be divided by 61 to get the sample size on its own. And typing this into the calculator, you get a value of 29.5. And we'll round this to 30. So essentially we are just rearranging the equation for the variable we want. If you choose to rearrange the formula itself, from there you just plug in the values so you don't have to do much thinking later on. That's fine. If you prefer numbers on the other hand and find it easier to manipulate, then you can also do that. At the end of the exam, if you have time left over, you should probably put the sample size 30 into the formula. You might just find you've possibly made a mistake and could save yourself some marks. Use your answer to part A to calculate the number of males studying history that should be in our sample. This again implies we need to use the sample size of 30. This one's much more simple in terms of what you need to do. Most of the time, if you got A wrong, then you won't be penalized for that on this part of the question. The examiner will simply look at your answer to part A. If you applied the correct method, so basically use that number properly instead of 30, you should gain 4 marks. The number of males who took history was 52 from the table. The total, as again we saw, was 200. To represent how many should be in our sample, we need to write the proportion. 52 over 200 and then multiply it by the sample size or whatever your answer was in part A, type it into the calculator, round the answer, then you should get 8 as the final answer. The exam question was on the harder side of what you'll see typically, so don't worry if you didn't get it all the first time. One last thing we should go through is the advantages and disadvantages. It is proportionate to the population. This ensures groups are not over or underrepresented, and you'll see it best used when groups are wildly different sizes. However, this is a time-consuming sampling method, as has been this video. So, this was a long one. Please do like the video to show your support if you found this useful. You can see the next sampling method here if you're interested, or if you want to revise something else, have a look at this playlist.